Dr. Ankit Rao sir is available.
Hello, yeah, good evening, ma'am. I'm in the meeting.
Welcome, sir. Welcome, sir. Anga, madam, please.
Anja madam, please start.
Yes, yes. Okay. Thank you. So, welcome and good evening to you. Good evening to one and all. On the behalf of Department of Electronics and Telecommunication Engineering and the entire organizing committee, I, Ms. Anagham Alkapurkar, extend a very warm and heartfelt welcome to our today's resource person, Dr. Ankit Kumar Rao, sir. On the sixth day, session 13 of the AICT Atal sponsored 6-day online faculty development program. Welcome, sir. Dr. Ankit Kumar Rao, sir, is Head of Research and Development Cell at P3C Technology and Solution Private Limited. He is working as a head and R&D in perovskite solar cell development. P3C is a perovskite solar cell manufacturing company located in Minisar, Haryana. He is currently leading the R&D efforts in the optimizing material for higher efficiency and stability, leading to the fabrication of modules with over 20% power conversion efficiency. He is also responsible for scaling lab processes to pilot production, enhancing device stability beyond 200 operational hours, and developing cost-effective manufacturing techniques. Dr. Rao sir obtained his PhD degree from Department of Physics and Astrophysics, University of Delhi, in the field of organic light emitting diodes. He has more than 7.5 years of experience in the practical device development and fabrication. To date, he has authored more than 5 scientific publications in peer-reviewed journals and has obtained 4 international Best Presentation Awards. His research background includes the investigation of charge transfer mechanism in organic molecules, design and development of novel transition metal complexes of OLED applications, electrochemistry, and perovskite solar cells. He has good hands-on expertise in the thin film growth and deposition techniques and possesses strong expertise in a wide range of material characterization methods such as FTIR, NMR, UV, PL, and TRPL spectroscopy, as well as scanning electron microscopy, field emission scanning electron microscopy, and transmission electron microscopy, which are the powerful electronic microscopic techniques, and thermal stability analysis. Sir, we would be grateful if the final 5-10 minutes would be reserved for an interaction and question answer session with our participants. Thank you, sir. I request Ankit Kumar, sir, to start the session. Once again, welcome, sir, and good evening.
Hi, thank you so much, ma'am, for the introduction. Myself, Dr.
Welcome.
Ankit Rao, I'm the head of R&D department in the company. First of all, I would like to congratulate all the organizers for the successful conduct of this amazing development program. And I feel honored to be a part of this program. So we'll quickly begin with the presentation, and then we'll save some 5 to 10 minutes for the interaction. Will that be fine?
Yes, sir. Fine.
Okay, sure. Okay, so is my screen visible to all?
Yes, sir, it's visible.
Sure. Okay, thank you so much for the opportunity. The topic for today's presentation is development and optimization of perovskite solar cells. You all must have seen solar panels in your neighborhood, in your neighborhood parks or rooftops or traffic lights, etc. But what if I say that these panels which you see on your daily basis are not produced in India? Yes, you heard me right. India still majorly depends on other countries like China for production of these solar cells. But there exists a technology which can be fully developed in India, and India can produce its own solar cells. Impressive, right? Today we'll be discussing a similar technology, that is perovskite solar cells, and how they can be taken from lab to the field for commercial applications. We will begin with a quick introduction to the company first, our current location, origin, and aim. Then before discussing the development of perovskite solar cell, we will first discuss whether the production in India is a viable option or not. And if yes, then what are the challenges? Then we will discuss, this is just a minute. Yeah, sure. Okay, so after that we will discuss how perovskite solar cells provide a solution to these present challenges, and what is the current status of this technology and the major development challenges. After that, we will discuss our company's achievement. That is, there I will also introduce to you all our two products, and after that we will conclude the presentation with discussing all the timelines and commercialization plans of the company. Okay, so this is a small introductory video of our company. So he is Mr. Suraj Kumar. He is CEO of our company. Oh, so yes. So the person which you're hearing right now, he's our CEO, Mr. Suraj Kumar. So as you all know, P3C is India's leading perovskite solar cell manufacturing company, where P3C stands for photovoltaic and photovoltaic processing components. We started at IIT BHU, from where our CEO graduated from the Department of Ceramic Engineering. During his BTech, he started working on the project on a perovskite solar cells with Professor Dr. Mohammad Imtiaz Ahmed, who is also our chief scientific advisor of the company. An insightful discussion between an enthusiastic student and the optimistic professor laid down the foundation of P3C. After that, we incubated at IIT Delhi, and after working for almost 2 years, we decided to take the work from lab to the field, and then we established our first research facility at Gurugram, where we worked on the scaling of this technology. And currently we are located at Manesa with a 50 kilowatt production capacity and a dedicated team of researchers for development and optimization of these perovskite solar cells. So this is the front view of our company. The vision of the company is very clear. P3C aims to deliver sustainable energy at affordable prices to each and every person on this planet, and to make India a global leader in the field of perovskite solar cell manufacturing. But what makes us believe that we can achieve this dream? So let me tell you that we at P3C, we are not just developing the technology, but also are developing all the equipments and the machinery that is required for the production of these solar cells in India. So the product which I'm talking about today is completely a Make in India product. We are not dependent on any other country for development of these solar cell in India. We are independent not only in terms of technology development, but also for the equipment, machinery, and the raw materials as well. But yeah, before starting off with the solar cells, let's first discuss whether the production in India is a viable option or not. So let me tell you that you will be glad to know that Surya Devta ki hum par bahut kripa hai. We are blessed with almost 300 sunny days annually, and if just 1% of India's land is covered with solar panels at 15% of efficiency, it could generate up to 1000 gigawatt of power. Then what's the problem then? So the current challenges in with the conventional technology is that we have a lot of manufacturing dependencies. The wafer itself is not available in India, and we are still dependent on a huge amount of raw material that is required for the production of these solar cell in India. So therefore, we're dependent on other countries like China for development of this technology. Also, the cost of implementation of the conventional technology is very high. And since they are rigid and heavier, therefore, there are very limited installation options for this. And one of the major challenges for production of solar cell in India is that we all know that India is a very densely populated country. So, creating a acquiring large lands for creating solar farms without displacing communities is, let me tell you, a very delicate act of balancing. Okay, so what's the solution then? So perovskite solar cells provide a solution to these challenges. Perovskite is basically a multi-layered third generation thin film solar cell that can be deposited on variety of substrates. By variety of substrates, I mean glass, plastic, or metal, etc. The main advantage of these solar cells is that the backup of this material can be tuned, and it can be made to work in low light as well, which increases their operational hours and all-day generation. Due to this, they are also suitable for the indoor application as well. And since they are solution processable, therefore has a very low cost of production. And since it can be developed over flexible substrates, so they are very lightweight, flexible, and possess strong applications in the defense, space, automobile industry, etc. And hence, these perovskite solar cells carries a potential to revolutionize the renewables energy sector in India. So there are two possible device architectures for the perovskite solar cells: a regular NIP architecture and an inverted PIN architecture. Both architecture possess the same perovskite observer, but the main difference lies in the sequence of the electron transport layer and the hole transport layer. In NIP structure, the light enters from the ETL side, while in the PIN structure, the light enters from the HTL side. Therefore, in one case, we require ETL to be transparent, while in the other case, we require HTL to be transparent. Okay, so while NIP structure has delivered the highest efficiencies, PIN structure, on the other hand, offers low temperature processing, better operational stability, and hence emerging as a preferred choice for the stable, scalable, and industry relevance. So, both structure, however, either NIP or PIN, consists of different thin layers, each having its own perspective. The first layer is a transparent electrode, which is also known as transparent conductive oxide. It allows the light to enter the device and also serve as the bottom electrode. The main and the most common example for these TCOs are ITO and FTO, which you also have used in your laboratories as well. Then we have transport layers, that is electron transport layer, that is ETL, and a hole transport layer, that is HTL. The sole purpose of these transport layer is to reduce the interfacial barrier at the interface and also the smooth transfer of charge carriers from the perovskite absorber to the respective electrodes. Perovskite is again the main active layer in the cell, which absorbs the sunlight and generates electron-hole pairs. Then finally, we have a top electrode, which also which collects the charge carrier and serves as the top electrode. So there are many options for the top electrodes. For example, copper, silver, gold, carbon, etc. The choice of all these layers is very crucial in order to have high efficiencies, because The minimum will be your interfacial barrier, the higher will be the efficiency of the device. So we choose the uh, we choose the layer in a manner the interfacial barrier should be minimum. Okay. So in the present scenario, the PSCs are emerging as strong competitors to the conventional technology in terms of efficiency. For currently, the lab scale efficiency of glass perovskite solar cells has reached 26.1%, while for the larger area, the efficiency has reached up to 19.9% at 810 centimeters per area. On the other hand, for flexible, the highest reported efficiencies are 23.8% for the lab scale and 11.8% for the large scale at area of 400 centimeters square. There is one more configuration, that is tandem configuration. Tandem configuration is advantageous in the sense that we can generate more energy in the same area. So tandem configuration is basically a combination of a silicon solar cell and a perovskite solar cell. So as we all know that the silicon solar cells work in the IR region. It there and ABXE, the perovskite solar cells, it work in the UV and the visible region. So using both cells in the same area can absorb more of the energy of the solar spectrum, and hence you can utilize the whole solar spectrum to generate the energy in the same area. So you can generate more energy in the same area if you are using tandem solar cells. So the efficiency for tandem solar cells has reached a skyrocket of 33.2% on the lab scale, while 26.8% on 1.7 meters square for the large area. So this is a huge number, to be honest. This is the list of perovskite solar cell companies from the worldwide and their production capacity status. So Microquanta is a Chinese company who are already running a full-fledged 120 megawatt production line for perovskite solar cells. GCL is again a Chinese company with a 100 megawatt production line. Oxford PV has also set up their production line in Germany for a 100 megawatt pilot line. Also, there are other companies like Wonder Solar and Atmolite who has already set up their production lines, respectively. The point to be made here is that perovskite solar cells, which once was a myth, is now breaking all these stereotypes regarding their stability and large-scale manufacturing. And the world has already realized its potential. People outside India have already set up their production lines, and the race to dominate this market has already begun. And if India does not act decisively now, then we will be left behind. So what is stopping us to enter the market? What are the major challenges? The major challenges that one face for development of these perovskite solar cells in India is first is the cost. So we all think that the cost of these perovskite solar cells is higher than the silicon solar cells. But let me tell you that the projected cost of production for perovskite solar cells is relatively lower than the conventional technology that we are using right now. The reason for this is that since they can be developed over glass or flexible or metal substrate, therefore the raw material required for the production of these solar cells is very easily available and very abundant, and hence the cost of production is very low. Also, they are solution processable, so not high-end machinery is required for the production of these solar cells, and therefore these solar cells possess lower cost of production as compared to the silicon. The other major concern is the lifetime and stability of the solar cells. So let me tell you that the proper encapsulation techniques and processing environment yields better stability. And yes, the current lifetime of perovskite solar cells is almost around 4.5 years, which is very lower as compared to the silicon, which have a lifetime of almost 25 years. But since the PSCs, the perovskite solar cells, can generate in low light as well, and hence they have longer operational hours, they can generate almost equal amount of energy in 15 years as compared to the silicon in 25 years. Efficiency, as I already discussed with you, that efficiency for these solar cells is now, touching new sky high levels. and is now comparable to that of silicons. The last but not the least concern for the manufacturing of this solar cell is the scalability. How to scale them for the manufacturing is the topic of debate. But it is also not longer the topic of debate now, because we have a variety of scalable techniques for the production of these solar cells. Um, for example, people has already achieved almost 20% efficiency on 30 centimeters square area using blade coating techniques. Also, the similar results have been achieved for slot die as well for the 17 centimeter square area. There are other methods as well, like inkjet printing or spray coating or vacuum evaporation, through which you can scale these solar cells. And hence, these challenges are no longer a major of concern for us. And this is where the role of P3C comes. Our technology and research has grown to an extent where these problems are no more a problem, no more a concern of us, concern for us now. Therefore, it gives me immense pleasure to present to you all our game changer product that is Mycen. Mycen is our trademark, which is basically a perovskite solar cell. We are developing this product on almost two types of. Right now, we are working on two types of perovskite solar cells. That is one based on glass and other based on the flexible solar cell. So this is Mycen glass. Mycen is our trademark. So Mycen glass is a perovskite solar cell which we have developed over sturdy glass substrates. And we have achieved up to 20% power conversion efficiencies on these solar cells in uncontrolled situations. So that is a point to be noted here, that we haven't developed these solar cells in the glove box or any controlled situations. They are all the efficiency reporting here is the efficiencies in the ambient condition. This product is Mycen Flexible. Mycen Flexible is a product which we have developed over flexible PET sheets, and they can be applied to places where conventional solar cells cannot be applied. So the processing of these two products, the glass and the flexible, is very similar. However, the substrate is the only difference in them. So these solar cells goes over different stages of the fabrication. For example, ranging from thin film depositions to the top electrode, then encapsulation, and after that it goes under the testing. Once you will overcome all these problems, then this is how the scaling of the modules will look like. So I have shown here our range of modules from 2 centimeter to 1 feet, which we are working right now. So this is a 2 centimeter perovskite solar cell with a power of 7.3 milliwatt. This is a 2-inch module with a power of 0.3 watts, a 4-inch module with a 0.9 watt power, a 6-inch module with a 3 watt electrical output power, and 1 feet module with a 9 watt of electrical output. These are the certifications that we have achieved so far with the help of dedicated team of researchers, and it gives me immense pleasure to tell you that we have achieved up to almost 20% efficiencies on our products in uncontrolled environment. So this is one of the major achievement which I consider we have achieved so far. So we are working on different projects in the company right now. These I'm just discussing two of the project due to the time restrictions here. One of the project we are working on the two-wheelers. So this is a two-wheeler with a total surface area available is around 0.798 meters square. And after 15% losses, we have checked the usable area will be around 0.678 meters square. The effective capacity of this system will be around 108 watt. So what we are working on, we are planning to paste our flexible solar cells on the body or the available usable area of this two-wheeler, and this will enhance the range of this So this is a EV, electrical vehicle. So it will uh, uh, charge the battery of the vehicle, and it will give you the enhancement, range enhancement in the kilometers of around 8 to 10 kilometer. Our team is dedicatedly working on this product to enhance the range from 20 to 30 kilometers for this product. Another project which we are working on is for the four wheelers on the commercial vehicle applications. So this is a model of the Tata Ace. You must have seen Tata Ace in your neighborhood. So what we are planning to paste perovskite solar cells on the rooftop area, the arrowhead area, and the side panels. So this the effective system capacity of this will be around 1.2 kilowatt, and this will our solar cells when it will be mounted on this vehicle, it will give you the range enhancement of around 80 kilometers. So we are working with two different companies, major companies in the field of e-vehicles. With them, we are developing this prototype. This is our next step of production. So our initial set of modules will be supplied to NICE. NICE is National Institute of Solar Energy, which is located in Faridabad, Haryana. So we'll be providing them 2 kilowatt of solar perovskite solar cells for all the field testing and accreditations that has to be developed, and for all the testings and the standards that needs to be established for perovskite solar cells, manufacturing of perovskite solar cells in India. We are working with Tata Motors for e-vehicle application, as I told you about that Tata Ace product. Also, with Tata Power, we are working on the field and rooftop application. So we'll be providing them 1 kilowatt system for all the field and rooftop applications of our product. Also, we are working with Indian Railways and the DMRC for the field trials as well. So we'll be providing them 5 kilowatt of panels for initial testing. So these are all the uh, orders that has been lined up for this year. So we'll by the end of this year we'll be sending all these uh, orders to the different our customers. So this is the timeline. So we are currently at this stage. So we have a 50 kilowatt of production capacity right now. We are trying to and we are aiming to increase it from this to the 3,000 megawatt of production by the end of year 2029. And this is our prospective commercialization plan. So if you'll see the product, Mycen glass, it currently costs you around 300 rupees per unit, which is way higher for the as comparable to the silicon solar cells. And the reason for that is the production capacity is very low. So we have almost 50 kilowatt of capacity, due to which the cost of production is very high. Once the production scale will reach from this to the 1,000 megawatt of scale, the projected cost of this product will be around rupees 12 per unit. So silicon cost you around 20 to 22 rupees per unit. This Mycen glass product will cost you around rupees 12 per unit once the production scale will reach to the 1,000 megawatt. Similarly, for the glass, it is costing us around rupees 800 per unit. But once the production will reach down the margin of 1,000 megawatt of scale, then the projected cost of flexible solar cells is around rupees 30 per watt. So this is 30 per unit. So this is the projected cost. And let me tell you that flexible solar cells is the future of the renewable energy and many of the companies are now developing these solar cells in India and also abroad as well. So these are our supporting agencies: IIT BHU, IIT Delhi, National Institute of Solar Energy, NICE. They are all our supporting agencies. FIDT and Oberoi Thermit are our investors, and Oberoi Thermit, Tata Power, and Tata Motors, and also there are some big players like Honda and Mahindra. They are also our major customers. With this, I would like to conclude my presentation. Thank you so much.
Participant, any question from your side? Participant, any question from your side?
Hello, sir.
Hi, yeah.
Sir, suppose researcher want to some fabrication get some fabrication work. Is it
Okay.
possible to collaborate with you?
Yeah, sure. Why not? We can do it because we are already fabricating solar cells here in Manisa. So that can be done. That can be easily done. That's not a
Okay,
problem.
okay, sir.
Anyone having any question? Sir, as compared to our day-to-day life vehicles which we are using that and the vehicle which will be launched by the solar panel, whatever you have shown, two-wheeler and four-wheeler, which
Right.
is more efficient and economical?
Uh, so you're talking about vehicle integrated photovoltaics, I guess, right?
Yeah.
So, see, the solar panels that has been installed right now, so silicon is basically not transparent, right? What we are doing here is perovskite solar cells give us the advantage. So there are two applications. That is, one is vehicle integrated photovoltaics, and other is the building integrated BIPV. So since these solar cells are developed over glass, so just imagine you're having a window at your home which is also generating for you energy for you. It is transparent, it is generating energy for you. So perovskite solar cells give us the advantage. तो अगर हमें व्हीकल जैसे फॉर एग्जांपल ये तो अभी हम लोग कमर्शियल एप्लीकेशंस के लिए कमर्शियल व्हीकल्स के लिए ही कर रहे हैं बट वंस इट विल कम टू दी पर्सनल व्हीकल्स पे अगर हम लोग को जाना पड़ेगा और उसके लिए तो बट वी आर प्लानिंग इज तो जो सनरूफ आपका होता है that sunroof will automatically be developed a solar cell. The solar cell will be developed on that sunroof only. So you can use it as a sunroof as well, and you can also use it. It will also charge your internal electronics of the car.
Okay, thank you, sir. Participant, any question from your side? Please unmute yourself and ask the question. Sir, few participants required your email ID or phone number. If they are having any doubt, they may ask you on your mail.
Okay, sure. Just a minute. I'll.
Yeah.
This is my email ID. It is ankitrao@p3ctsl.com. So if anything you want to question, you have any doubt or you want to inquire about anything, you can just email me and we'll reply back to you.
Okay, thank you.
Okay, thank you. Thank you so much, ma'am.
Yeah. Okay. On the behalf of management, principal, and Atal FDP organizing team of AC Patil College of Engineering, EXTC department, I express my deepest gratitude towards Dr. Ankit Kumar Rao sir. His talk will greatly benefit researchers and professionals, those who are working on fabrication work and perovskite solar cell material. I also extend my gratitude to the Atal FDP organizing committee, faculty coordinator, and all participants for their support and active participation, which made this session as well as whole program of 6 days successful. Without participant, nothing can be success. So special thanks to the participants. Once again, thank you all for your valuable presence, patience, and cooperation. And special thanks to our today's guest, Dr. Ankit Kumar sir. With the permission of organizing committee and the coordinator, I would like to declare that the session is concluded.
Thank
And
you.
the session is handed over to Dr. Rajni Maurya, madam. Thank you, sir. And thank you, participants.
Dear participant, please be connected. I'll be back in 2 minutes.
Okay, fine. Sir, can you please stop the recording for this session? Got it, sir?
Yes, madam.
Okay. Thank you.